The CrowdStrike platform is the ideal solution for threat hunting. The endpoint sensors are constantly monitoring activity on the endpoint and streaming it to the CrowdStrike threat graph in the cloud. Storing the data in the cloud is critical. It means that we always have access to the data, even if the machine is offline. CrowdStrike is unique because in addition to sending raw event data, we also put it in context. We can tell what happened before, during, and after an incident. In fact, we can dynamically increase the fidelity of what we collect if an intrusion is suspected. The result is a dramatic reduction in the time it takes to perform forensics, but the same data set is incredibly powerful for proactive threat hunting. There are two primary ways to perform threat hunting in Falcon Host. However, it should also be noted that we can stream data to other systems like a SIEM via our API. This is useful if you prefer to do your threat hunting with an existing tool. The first way is with the Investigate app. This app is built to take the complexity out of threat hunting. We make it easy to look for common indicators. Examples include file hashes, IP addresses, and domain names. Let's take a quick look at the Investigate app. Oftentimes, threat hunters are provided new bits of intelligence and are then asked, have we encountered this? Or are we impacted by this? To illustrate this example, let's look at some brand new bad domains from Malware Domain List. If anyone in my environment has connected to these domains, then there may be an active threat in my environment. So we start by collecting the bad domains. We could do this by copying and pasting each domain, but CrowdStrike simplifies this by providing a browser plugin called CrowdScrape. This automatically grabs the indicators off the page and copies them to the clipboard. Now that the indicators are copied, I can paste them into the bulk domain search feature of the Investigate app. In this case, we have good news. Nobody in my environment has connected to any of those bad domains. Just to ensure the feature is working, I'll update the query to include google.com, and you can see hits coming back in real time. The next thing we want to look at is file hashes. Threat hunters often leverage intelligence from trusted sources like SANS to influence their hunting. In this case, there's a SANS post about a new piece of ransomware delivered by an exploit kit. We can see all the details of the attack in the post, but again, my interest is understanding my exposure to this threat. So I go back to CrowdScrape, but this time I copy the file hashes. In the Falcon Host UI, we switch over to the hash search feature. We do a quick search on the threat graph, and this time we get a hit. One system in my environment has encountered that malware. On this results page, we get some of the context for this threat. We have things like process execution history and detection history across my entire environment. Since only one machine was impacted, I want to drill down into that machine to better understand the impact. We now pivot to a screen that shows all activity for that machine. So if the malware did something like try to connect to other systems or make changes to this system, I would see that in full detail on this page. We see details like IPs that the machine has connected to, changes to the file system and registry, executables written, all process executions, admin tool usage, focus on PowerShell activity, DNS and network connections, any scripts that were written. We even see things like removable media usage and data exfiltration activity. The dataset really is comprehensive, and you can see that most of the items are links, offering even more ability to pivot and drill down. What we want to do next is move beyond the concept of just looking for indicators and actually investigate a suspicious individual. We start this process by looking at our high-level dashboards. Here we see a list of users with lots of detection activity. Let's take a look at this AZIA user and see what's going on. This time, instead of seeing all the details of a given machine, we're seeing all the activity associated with a given user. We see that we detected suspicious activity on his machine 4 times in the last 2 weeks. Based on this, it looks like he's being targeted. We see a handful of exploit attempts, and eventually we see malware attempting to run. The good news is that we prevented the infection, but I'm still curious to know why this happened and how the attacker was finally able to get malware to run on the system. To see this, I simply click on the description and I get taken to the detection details page. Here I can see the processes that preceded the attempted installation. And I can also get things like execution details, file reputation information, network connectivity info, and even the DLLs that it referenced. Based on all this activity, I'm pretty sure the user is being targeted, so I decide to take a system offline until we get a better handle on the situation. To do this, I simply click on the network containment button, and then confirm the selection. And now that at-risk system is offline and ready for further investigation. Up next, we're going to move to the Events app where we do more advanced threat hunting. The purpose of the Events app is to give power users complete access to the data in the threat graph. This enables much more creative and advanced threat hunting. We use the Splunk query language, so familiarity with Splunk or writing structured queries helps a lot. We realize not everyone is a query ninja, so we put together a threat hunting guide. This takes the top recommendations of our team of experts and puts pre-made queries at your fingertips. In this demo, we're going to look at 3 of those queries. The first one looks for encoded PowerShell commands. While it is normal for administrators to use PowerShell, it is not normal for them to encode the commands. If you see a lot of encoded PowerShell in your environment, then it is very likely that an attacker is working inside your environment. So here I just copy the query and paste it into the Events app. In seconds, we search the threat graph and discover a handful of encoded PowerShell commands. We also see a histogram, which helps me understand if this activity is common or anomalous in my environment. This indicates a risk, and I now have the choice to drill down into each of them to understand if it was legitimate or malicious. The next thing I want to do is identify suspicious network activity. I know that there are a number of applications that should not be calling out to the internet, and if they are, then it indicates a threat. So again, I'll take this query and paste it into the Events app. Here, I see a bunch of Microsoft Office 365 stuff, so it makes sense that it's calling out to the internet. But if it was vulnerable versions of Word or Excel, I would be much more interested and would drill down to investigate further. The last thing I want to investigate is use of the local system account. Good security practice says that web servers and database servers should run with dedicated accounts with limited privileges. So if you see these processes running as local system, it may mean the server is compromised and the attacker has elevated privileges. So we take this query and paste it into the Events app. We get 4 hits, and each of them is a web server. This means either they were not properly configured or they have been compromised. Either way, I'm glad Falcon Host could show me this, and now I can take action on those servers. These were just 3 quick examples. The important thing to understand is the breadth of the data available in the threat graph and the speed at which you can access it. This is what truly sets the CrowdStrike Falcon platform apart.